All right, welcome to the Explainer. Today, we're going to pull back the curtain on the invisible shield that protects your data, literally every single second.
So let's kick things off with a question that's honestly super important for pretty much every single app you use. In a world of just constant digital chaos, how in the world do databases make sure your data stays correct and reliable?
Okay, so before we can really appreciate the solution, we've got to understand the problem, right? Let's dive into what I like to call the data danger zone.
And look, these aren't some far-off theoretical issues. This is real life. Your app crashes right in the middle of something. The whole server just loses power. Or, two people try to book the exact same airline seat at the exact same time. Without a safety net, any of these super common things could just destroy your data for good.
So, what's the brilliant, elegant solution to all this potential chaos? Well, it all comes down to a powerful concept called a transaction. And this is the absolute key right here. A transaction isn't just a to-do list for the database. No way. The database sees it as one single, indivisible thing. It's all or nothing. It either all succeeds or it's like none of it ever even happened.
The go-to example, the one everyone uses because it's perfect, is a simple bank transfer. To you, it feels like one action, right? But behind the scenes, it's actually two separate steps, taking money out of account A and then putting that money into account B.
And this slide just lays it out perfectly. It shows that all or nothing promise in action. On one side, without a transaction, if the system crashes after step one, poof, the money is gone. It left one account but never made it to the other. Your data is now totally inconsistent, just broken. But with a transaction, any failure at any point means the entire thing gets wiped clean. The money is either transferred or it isn't. Your data stays consistent. Huge difference.
So, how is this incredible reliability actually guaranteed? Well, it's through these four key properties. Think of them as the gold standard for databases, and together they're known as the ACID test.
Yeah, let's picture this as a mind map. You've got ACID right there in the center, and branching off from it are the four essential promises a database makes to keep your data safe. So let's walk through each one of these branches.
First up, our first branch is A for Atomicity. And this is exactly what we were talking about with the bank transfer, that all or nothing rule. The entire operation is treated like an atom. You can't split it. It's indivisible. Okay, next branch. C is for consistency. This one's pretty intuitive. A transaction just can't break the database's own rules. So if there's a rule that says an account balance can never go negative, then any transaction that tries to do that will just get rejected. Simple as that. It keeps the data valid and logical. Then we have the I branch for isolation. And this one is absolutely crucial for that whole two people booking one airline seat problem. It basically makes sure that my transaction can't see your half-finished work and you can't see mine. It's like we each get our own private little sandbox to work in until our changes are totally final.
And our final branch, D, stands for durability. This is the ultimate promise. Once the database tells you your transaction is committed, that it's done, those changes are permanent, period. They're going to survive a power outage, a server crash, you name it. Your data is safe.
Now, the really cool part is that these incredibly powerful ACID guarantees, they're not just some abstract theory. We can actually get our hands dirty and control them ourselves with just a few simple SQL commands.
Let's take a look. Here's what that successful bank transfer looks like in actual code. You start the block with begin transaction. Then you do your operations, in this case, the two update statements. And since everything went smoothly, you lock it all in with commit. That's the command that makes the changes permanent and durable.
But, what if something goes wrong? In this example, we try to withdraw way more money than is actually in the account. That's going to violate a consistency rule, right? So the operation fails. The application then issues a rollback command, and that just erases everything that happened inside the transaction. It's like it never even started.
So what this means is that every single transaction has a very clear life cycle. It starts out as active while it's executing its commands. After the very last command runs, it hits this brief partially committed state, and from there, it's a fork in the road. If everything's good, a commit makes it permanent, but if there's any error or an explicit rollback, it gets sent to the aborted state, and it's wiped from existence.
Okay, let's zoom out for a second and really lock in the big picture here. What are the key takeaways from all of this?
The main idea is actually simple, but it is so powerful. Transactions are the fundamental unit of work for keeping a database safe. They are defined by those four amazing ACID properties, which you, the developer, can control with simple SQL commands.
This whole system, this is what stands between your precious data and complete chaos.
And that's our deep dive into database transactions. Now, to really make sure this all sticks,
As you go on your way, maybe ponder a few things. Like, which one of those ACID properties guarantees your data will survive a server crash? And why is isolation so critical in a world with tons of users all doing things at once?
And what's the real power behind that rollback command? Think on that. Thanks for joining us on The Explainer.